So we're going to read out something that's called the remainder theorem. Now we've already actually seen this whenever we've been looking at the previous couple of videos, but it just wasn't written in this format. But this remainder theorem says that if we've got a polynomial, and we'll call the polynomial f of x, and if it's divided by some value x minus h, then the remainder is going to be f of h. Now that's a bit of a mouthful, and the chances you looking at it the very first time and saying, oh yeah, I completely understand that, are going to be pretty slim. So we're going to go ahead and we'll have a look and see why we write this in this form and what it means. And it'll become apparent whenever we do that, because we've actually already seen it. We just don't know, because we're just not used to looking at it in these terms. So let's go back to what we had originally. We had some number 43. We divided it by a value of 7 and we got 6 plus 1. Or equivalently we could say 43 is equal to 7 times 6 and the remainder is 1. So we say that the divisor is 7, the quotient is 6 and the remainder is 1. And then we went on and we looked at, rather than doing it just by numbers, we decided to do that with polynomials. So what we did was they said we were going to take this polynomial here and we're going to divide it by that polynomial. And whenever we did it, we ended up getting this polynomial here plus the remainder. So this is just the same as what we've got above here, but we're doing it for polynomials. So then for what we can say is this polynomial here will equal this polynomial times this polynomial, and we'll end up with a remainder of 62. And that's all we have up here. It's saying the polynomial f of x, so that's this one here. If it's divided by some other polynomial x minus h, well, that's this one here, x minus h. Then the remainder is going to be, now this is the main point here, the remainder in this case is going to be 62. But 62 is simply the value that you get whenever you put your 2 into this polynomial. So if I put 2 into here, so I do 5 times 2 cubed plus 2 times 2 squared plus 8 times 2 minus the 2, I'll actually get the number 62. So let's go ahead and we'll actually just do that just to prove that that's the case. So we're going to have 5 times, well, 2 cubed is going to be 2 times 2 is 4 times 2 is 8, so it's going to be 5 times 8 plus 2 times 2 squared, so it's going to be 2 times, well, 2 squared is 4 plus 8 times the 2 minus the 2, so that's going to equal, well, 5 8s are 40, 2 4s are 8, and we'll get 8 2s are 16, minus the 2, so that's going to give us the 40 plus the 16, we give us 56, plus the 8 is 64, minus the 2, which is going to give us a value of 62. So the main point here about this remainder theorem is that the remainder here is just going to be the value of the polynomial at the point where x is equal to the value of 2. So we'll go and we'll have a wee look at that actually on the graphical calculator, and we'll see exactly what this equation looks like, and we'll find out that this does actually work and the remainder theorem is as what's stated up here. So don't get too worried or too bogged down whenever you see all of this. What matters is that we're able to go through and work through the examples, and you can see from the examples that we've done so far that the actual process of working through this mathematics is relatively simple. So we've got our equations in the graphical calculator. So this was our original equation here, our 5x cubed plus 2x squared plus 8x minus 2. So this is it in red. Now maybe not the best equation to choose, it looks a little bit narrow, it's a bit more awkward to see, but we can still work with it. So we're taking that equation and we're dividing it by x minus 2. So that's our equation x minus 2. So every point in this equation here will divide every point in this equation here. So we said that this here, 5x cubed plus 2x squared plus 8x minus 2, well that's going to be exactly the same as our x minus 2 times this function here. So we'll have divided that out and we've got this here as the quotient and we've got the remainder as 62. So if this is correct, whenever I click on this one, it should draw a graph straight over the red function because we're just saying that this here is the same as that. So we click there and the purple one is just drawn over the red. So that function here, this does equal this here, so it is correct. But now we want to have a wee look at this value of 62. The 62 should be the value of this function here whenever the x is equal to a value of 2. So this is the red function here. So when x is a value of 2, the y value should be 62. So let's go ahead and we'll have a wee look. So we head up towards 2. So 1.97, and there we're heading towards 2. And you can see at 2, we have 2 is exactly equal to 62. So that means that the remainder theorem is correct. The value of the remainder is just the value of the function at the point given by this value here, which is 2.